Well, good evening, everyone, and welcome from my side as well. So, can we do science with aliens? I mean, we all know the stories. The aliens arrive. Finally, we find out the deep mysteries of the universe. Or maybe we go exploring and find an ancient civilization long gone, having left the library for us with all the wisdom. Oh, maybe I should just go better.
Yeah, thanks.
Okay, so we all know these stories, but these stories raise two questions. The obvious one, are there aliens? But the less obvious one, perhaps, if there are aliens, can we actually do science with them? What might the pitfalls be? And actually thinking about that question leads us to some interesting questions and views of our own world. I want to start with a warning and a disclaimer, though, given that there are astronomers in the room. This talk will contain some clouds. If you're a sensitive listener, look away. And then the disclaimer, as you can read, folks with a PhD have a certain habit of believing that they know everything. You should not believe them. And that specifically includes the one standing in front of you right now. Also, I should point out that this talk is based on this lovely book, which I think is available in South Africa now. And in particular, all the nice cartoons you will get to see stem from this book. But moving to the real talk, are there aliens? And an astronomer came up with an equation to give an answer to that question, now known as the famous Drake equation. He picked it here, which basically just tells you that the probability of finding aliens is a product of all sorts of factors. And in particular, at the time when the Drake equation was first written on the blackboard, I would say it was just an elaborate way of saying we have no idea. That has changed a bit in the meantime. So let us go through these factors. How many stars are there? How many planets are there around them? How many habitable planets are there? Is there life? Intelligent life? Maybe even civilizations? And then how long do civilizations last? Let's start with a simple one. How many stars are there? Now, in practice, it may not be so easy to count them for obvious reasons, but we have a fair estimate, and that is that there are roughly 100 billion stars in the galaxy, give or take a factor of 10, I guess, and there are about 100 billion galaxies in the universe. That is a lot of stars, 10 to the power of 22, actually. But if that number looks big to you, let us put this number into perspective. With this quote from Genesis, the blessing of Abraham, that you will have descendants as many as stars in the sky or sand grains at the beach, which of course raises the question, which of the two is better? Are there more stars or are there more sand grains? And obviously you can do the mathematics, you Google for the numbers, and I will not go through the details, but the bottom line is that there might be more than 10 to the power of 23 grains of sand in the Sahara alone. So the sand grains probably win. So much for many stars in the universe. Still, 10 to the power of 22 stars is a lot. And most certainly that should mean a lot of opportunity for planets. But how many planets are there? Now, we are fortunate that we are now at an age where we can actually even do statistics with planets. So we know with good confidence of 6,150 planets, at least as of the 19th of March. That number, of course, keeps changing. And here's actually an illustration of how the number has grown from 1995 up to now. I mean, it's quite impressive to see that over 30 years, our view of planets changed completely from we don't really know whether there are any up to, okay, they're quite common, let's do statistics. But just having a planet on its own is, of course, not enough. Because, I mean, planets around other stars are nice, but if you're looking for planets with life, they should be habitable. And traditionally, so you can come up with a habitable zone, that is the zone around the star in which there can be liquid water. The whole concept is problematic a bit for two reasons. Reason number one, we can still have liquid water beyond the habitable zone. Ask Europa, which probably has a liquid water ocean underneath its surface, not because the sunlight would be sufficient, but simply because of the gravitational effects of Jupiter. So that's one problem. We may have habitable planets outside the habitable zone. And then, of course, this is the first time in this presentation where a bias might sneak in. We are looking for planets with water. So our assumption is you need water for life. That may be completely wrong, of course. It's just that the only life we know needs water. So who knows? Maybe that criterion is not that conclusive after all. Still, it is the best we have, the best we know. And even within our own solar system, at least historically, there has been more than one planet in the habitable zone. Most notably, Mars was in there as well. And indeed, I think about a year ago, or maybe two, NASA actually released findings that I think Perseverance had found a rock with these leopard spots, which are actually made of chemicals which, at least on Earth, are a sign for microbial life. Now, NASA was quite clear on that this is not proof, nowhere near. But it is at least a sign that maybe life exists elsewhere, or at least existed elsewhere, even in the solar system. Now, of course, that leads to the question, how would we find life? And actually, people, of course, have come up with some scale of confidence of finding life. And I will not go through that. I will just point out, if you look at that, it's not easy, right? Just finding one chemical does not really mean that you have found life. But really, you want to find a second sign, and then you want to make a prediction that you should find something else associated with that life. And if you find that as well, then perhaps you have found life. I guess the easier way would be to get a message from them, but we can't be picky. But now I have mentioned life so often in this talk already. What is life? And that's a difficult question. Maybe the best answer is you recognize life when you see it, but obviously that is not really a good definition. So the one by NASA put forward is that life is a self-sustaining system capable of Darwinian evolution. That makes sense, but has probably quite a few loopholes still. I mean, is an internet meme a life form? I mean, it is spreading, it is evolving. Is it self-sustainable? Well, maybe not. But are we self-sustainable? I mean, if you put me in a jungle, well, that would be the end of me. So maybe it's a bit ambiguous. And so what that really tells us is that we might have to be open-minded when it comes to life. We don't really know precisely how to define it. We don't really know what it might look like. So we have to see. But how probable is it that you will get life sort of in this definition if you have a planet in a habitable zone? And of course, there is a problem. We only have one data point. It's a bit difficult to extrapolate from one data point, but given that it is what we have, we might as well look at the history of life on our Earth. And there are a few milestones in life. Not all the dates are 100% certain, in particular the early ones. But what these days really tell us is that it seems that life on Earth came into existence pretty fast. It didn't waste much time. And that would suggest that life might be something which is not so improbable if you have the right conditions for life, which is good news. The not so good news for our talk is that if you then look further down, it takes ages before life decides that maybe multicellular life is a good idea. And even longer before it then decides that maybe going to land is a good idea and becoming intelligent might be a plan. As an interesting aside, when did life and evolution really kick off? It seems in the moment when life decided that an easy way to get energy is to eat someone else. Because then the arms race started and then evolution really kicked off. I'm not so sure whether that's good news, but so the bottom line is, from the evidence we have on Earth, I would conclude life elsewhere as such is likely if you have a planet in a habitable zone. Intelligent life, a completely different question. And then, of course, if you want to speak to a scientist, you not only need intelligent life, you need a civilization as well. You need people starting to make sense of the world, to paint cave images, and then at some point going to the moon. Okay, we've managed that part. That leads us to the last question, the time, right? And that might, of course, depend on the intelligence of life. And sometimes you may have your doubts about intelligent life on Earth. So that is, in a nutshell, the question answered: how likely is it that there is intelligent life? We still don't know, but there is pretty good evidence that we are not the only ones in the universe. And hopefully not even in the galaxy, in the Milky Way. There should be a lot of other habitable planets, and then there should be life. So let's assume for the moment that's a given. There are aliens, and we get a chance to meet them or to get a message from them. Then we can turn to the second part. What is happening beyond the great equation? Can we speak to them? Can we do science? Do they do science, actually? Can we ask, or are we asking the same questions? And would we actually enjoy the answers, make sense of the answers? What are the pitfalls? Let's start with science. It is tempting to believe that if we meet an alien, maybe even an alien coming to Earth, they should be doing science, right? Because how else would they have got here? But maybe that is a bit of a bias. Because if you look in Earth's history, I mean, people have been using poisonous arrowheads probably for 60,000 years. And 60,000 years ago, they probably didn't do much science. Never mind the fact that all sorts of other important inventions were made without any scientists around. Metallurgy, agriculture, and for some, maybe the most important one, beer and wine. So things started to shift a bit with the Greek philosophers, who now started questions as to why is the world the way it is. And then the Renaissance brought along the idea of that you can actually do experiments. You really asked hands-on questions to the world. Of course, that is a bit of an oversimplification. I mean, it's not that the Renaissance all of a sudden popped into existence without any predecessors. So take that with a grain of salt.
Sorry, can you just tell us about that? It was Galileo, it was Francis Bacon, but were there a whole lot of other people who were also thinking about doing experiments?
Oh yes, I mean, it's probably difficult to say that, oh, it was that person or that person. Right? I mean, they're all in the context, right?
Yeah.
And someone else might have come up with similar ideas anyway. So it's probably more about society and civilization more than about single people. But so it might very well be that if you have a civilization which has been around for millions of years, maybe they never bothered to come up with science. Maybe they just discovered all the cool stuff by trial and error, right? Like men did for so many thousands of years. But there is one aspect, at least, which basically all humans through all ages shared. They may not have to have done science in our sense. They may not have done experiments, but in a way, they all asked questions and they all wanted to have answers. And that means they told stories, right? They told stories about the creation of the earth. And there is one story that says that God created heaven and earth in 7 days, or 6 days. And then there are other stories, right? Like our universe came into existence with a Big Bang. Now, I'm not saying that these stories have the same quality, but they are both ultimately stories. We try to make sense of our world, extrapolating from what we know. And in particular, if we come close to the Big Bang, I once read a textbook on relativity where the author basically said that time immediately after the Big Bang, you might as well call the fairy tale era because we have no idea what happened. So anyway, so we don't know whether the aliens coming here will be scientists. There is a fair chance. Let's be optimistic. They are scientists. They do science. Now, that doesn't help us if we don't understand them. So, communication. And science fiction authors are traditionally very optimistic about communication. I mean, in science fiction movies, aliens speak English anyway. And if they don't speak English, you have a universal translator, right? Now, of course, looking at Google these days, you might be tempted to believe, oh yes, that's an easy thing, right? We will have a universal translator. There is one science fiction series episode which tells a slightly different story. And that is, I think, my favorite episode of Star Trek: The Next Generations, where the Enterprise meets an alien spaceship, I think manned by Tamarians. And while they have a universal translator, they have a problem because Tamarians basically have a language which is really built on metaphors, drawn from their history. And of course, if you don't have that context, you're lost. And so eventually the problem is overcome by the Tamarian captain beaming himself and Jean-Luc Picard onto the surface of a planet where they had to fight a slightly nasty life form. And unfortunately, the Tamarian captain died, but at least they made communication because now they shared the context. Now, you might say that, okay, this is all science fiction, right? But this whole context and needing context to really understand language is something you find on Earth as well. And for example, there is this Danish word, right? And don't really ask me to pronounce it. It's something like Rike. And I probably got that wrong. It's one word, right? But if you look that up in the dictionary, that is the definition you get, right? And what it really means is something like that, right? A whole experience based on so many things. And if you don't have that context, you have a hard time understanding that word. So language, understanding language is not easy. But even if we leave away these metaphors and extreme cases, deciphering languages is not easy. I mean, hieroglyphs are a good example. Egypt was one of the world powers for thousands of years. And still, at some point, people stopped using hieroglyphs and they didn't bother to learn or teach them anymore. And so people forgot how to read hieroglyphs. And then it took a lot of work to actually rediscover how to read hieroglyphs, what they mean. And we were lucky that we got a clue in form of a Rosetta Stone, which had the same text in 3 languages. I mean, and that's maybe an important message. And it's not the only such case, right? A language without speakers easily becomes a pretty dead and indecipherable language. So I'm afraid if we find the alien library on another planet without the aliens nearby, we might be stuck. Badly so. In particular, if there is no teach yourself alien language book in that library. And how would we understand that book? So, so on that note, how did we try to communicate with aliens? Well, while this may be a bit of a publicity stunt, of course, I mean, the Pioneer probes had this plug on board. And if you gave that to a human, they might make sense of it, perhaps. I mean, do you have an idea what that drawing at the top left means? Well, it's supposed to be a hydrogen atom, based on a model which is, of course, not correct, a grave oversimplification, based on the idea that, oh, radio waves are so important, surely aliens know that. Well, let's hope so. The guide to the solar system includes Pluto. Well, I mean, that is not a planet anymore, right? They might have trouble there. And let's just hope that raising a hand as a greeting does not mean I want to kill you in alien. Well. And of course, even if you speak to people, you have to be careful with nuances. And I like the story so much that I give them here. There is a folklore that the name Canada for that lovely country actually came into existence because an early explorer, Cartier, misunderstood the term Canada as the existing proper name of the Iroquois people's entire territory, rather than the generic class noun for a town or village. That is probably not true. It is true that the name Canada originated from the Iroquois word and from Cartier, but he probably knew precisely what it meant. As an aside, at some point, people had to decide what Canada is supposed to be called, and there were other suggestions. And maybe the funniest one is Tuponia. And that is an acronym for the United Province of North America. Maybe we should be glad that that did not make the mark. So, we have seen language is difficult, and in particular, if you don't have someone to speak to. So, we really have to be as easy, as basic as possible. We have to find something which we share with the aliens. And what better thing to use than mathematics, right? So there is the story that an astronomer had the idea to actually dig large geometric figures in the Sahara and then put some gasoline in there and set them aflame. so that the Martians would see them, knowing that there is intelligent life on Earth. That's probably not true, that's probably a precursor, but it raises an interesting point. Can we use mathematics for basically starting communication? And it sure sounds like a good bet. And for example, Carl Sagan, this famous astronomer in his novel Contact, used precisely that idea. And you can make really clever arguments with that. Starting from something simple, ending up with real communication. And the idea behind it is that this whole world is based on mathematics, right? If you want to understand how radio waves work, you need Maxwell's equations, which are just fancy mathematics, right? And I mean, what could be more obvious than counting, right? 1 apple plus 1 apple makes 2 apples, right? And even crows can count, right? So what can possibly go wrong? Well, some people might think everything can go wrong here. Are numbers real, or are we making up numbers? And surprisingly enough, there is a philosopher who asked that question and who argued that, oh, well, I am denying that anything like numbers, functions, sets exists. Surprisingly enough, he managed to basically derive Newton's law of gravity without any numbers or such things. Don't ask me how. I had a look at the book. You can find it online. It is hard. It is really hard. There must be a reason why we are using numbers. But at least it raises this question, are numbers God-given? Or is it, at least to some extent, something man-made? Is it just our view of the world? Could there be other worlds? And let's face it, this 1 plus 1 is 2 does not hold everywhere, right? 1 cloud plus 1 cloud gives 1 cloud, and not 2 clouds. So maybe, and that is of course far-fetched perhaps, but maybe the fact that we count and that we build all our science on counting effectively has a lot to do with our environment as well. I mean, if we were a life form in the plasma, maybe we would not be counting like that, but who knows? But let's again be optimistic. We can communicate with the aliens who do science. Are we actually asking the same questions? Well, our questions ultimately are based on what we experience. And that is, of course, stunningly obvious if you look at light, right? We only see the visible light, and that means that for hundreds and thousands of years, all the questions we asked were about stuff you can see in visible light. And everything else we didn't care about, we didn't even know about it. And it's not only light, right? There are other particles, right? Like neutrinos, almost ghost-like particles. And if you want to find high-energy neutrinos from outer space, you would have to do things like go to the South Pole and drill 1 kilometer deep holes and let photon multipliers down so that they can catch neutrinos rarely interacting in the ice and then generating a whole cascade of charged particles, which in turn then emit light in form of Cherenkov radiation, which you then detect. Now, neutrinos are a bit cumbersome to detect because they almost never do anything. And there is one of my favorite quotes from Douglas Adams, who pointed out that the chances of a neutrino actually hitting something as it travels all this whole emptiness are roughly comparable to that of dropping a ball bearing at random from a cruising 747 and hitting, say, an egg sandwich. That is probably an understatement. I did a back of the envelope calculation, and it seems that hitting the sandwich is probably still about 100,000 times more likely than a neutrino interacting. So, and indeed, the chance that a neutrino will interact with your body throughout your whole lifetime is about 1/3. So you're lucky if you ever get hit by a neutrino. And to give you an idea of how many there are, if you hold your hand in front of the sun, billions of neutrinos will cross your hand each and every second. None of them will interact. Well, but of course, if you have big enough detectors, you can detect them. And there is some good news with that. Given that the neutrinos can move through the Earth unhindered, we finally have conclusive proof that when the sun sets, it is still there, because we can still see it, at least if we look in neutrinos. It gets worse. Vera Rubin, yes, the namesake of the Rubin Observatory from last month's talk, actually was instrumental in developing the idea of dark matter, because when you analyze the rotation speed of galaxies, you see that in theory, the rotation curve should turn down the further you get away from the core, but it basically stays constant. So there is more mass than we can see. There is dark matter, and there is much more dark matter in the universe than normal matter. And we have absolutely no idea what it is. If there is alien life based on dark matter, we wouldn't know, because we wouldn't even be able to, in air quotes, see it. And it sounds likely that they might have to do a completely different science, right? If they are concerned about dark matter more than our normal matter. They might ask completely different questions. And even in more earthly terms, it might be worth remembering that different experience, different ways of looking at the universe may yield different results. One bias astronomers have, and maybe understandably so, is astronomy is very visible. You look at images, right? But we should bear in mind that there are other senses, and that people who can't see can still experience the universe if we present it in the right way, right? If we turn photons into sound. And here's an example of that. So maybe let's keep in mind that what the questions we ask, the world we have, is of course based on what we see, but it's probably also based on what we think, on the models we have of the world. So it is maybe not as universal as we would like. And maybe as a point in case, we classify things, right? And to some extent, this classification may be arbitrary, right? Is Pluto a planet or is it not a planet? And if Pluto is a planet, do we ask different questions? Or at least do we ask different questions earlier than other questions? Just because we classify Pluto as a planet or whatever the case may be. Classification does not always work either. Neat separation does not always work. We have this idea of an electron being a point-like particle, but if you do that, you end up with something like negative infinity for the charge, right? Which of course doesn't make sense. It maybe just tells us that we can't separate the electron from the surroundings. So we have a conception of what the word should look like, but it is maybe to some extent just how we categorize the word. Of course, it is necessary to think in categories and to lump things together. Because, for example, if a tree is falling on you, it is a good idea to think of that level rather than of atoms as such, because you want to run away very soon. But here, and why this has nothing really to do with alien scientists, there is a bit of a mystery here. One thing we have learned is we can look at the world at different levels, right? We can look at whole galaxies or even interacting galaxies. We can look at the solar system. It's a complete different level, right? But we can come up with simple laws for the galaxy. We can come up with simple laws for the solar system, with simple laws for the Earth, right? And so forth, further down. Why is that a mystery? Well, if you look at individual particles, say, right, they are really unruly. They don't stay in one spot, right? There's a lot of probability, uncertainty involved, and I will come back to that in a moment. So really, a single atom is like a young child, right? A young toddler with which you want to cross a road. This young toddler will try to run in every direction off, right? You will have a hard time keeping the one toddler in the direction. If you have two toddlers, it would be even worse, right? Because now you have two toddlers going in all sorts of directions. And 3 and 4 and 5, it gets worse and worse, right? But it isn't toddlers, but atoms. No, because if you have many atoms, all of a sudden they don't go off in all different directions. They are a tennis ball, going all in the same direction. And yes, we know the physics, we know the mathematics, but it might be worth remembering it's a bit of a mystery why that works on so many different levels. And it's really good news because it means we can make sense of the world on so many different levels. And maybe that means that the levels we choose are not completely arbitrary. I mean, there are systems which do not have simple laws. I take the weather, for example. So maybe that is a system which we can't easily analyze in that way. So maybe we are at least lucky on that side. And finally, the kind of questions we ask depends on chance as well. Or at least the way science develops depends on chance. And to illustrate that, I have a pub quiz question. When was Neptune discovered? Anyone?
1848.
1848. That's a really good answer. 1846, right? Really? Chances are that Neptune was discovered in 1613 by Galileo. Again in 1730 by Lalande. 1830, John Herschel, but they just missed the fact that it was a planet. You could say the same for Pluto, but now imagine that if Galileo had realized that Neptune was not a star but a planet, how would that have changed solar system physics? How would that have changed science? We don't know, but it might have gone in a completely different direction. Finally, let's assume that we at least sort of agree on the questions. What about the answers? Can we understand them? And what are we actually hoping for? We are really hoping for an alien to explain the world to us, right? To come up with a world formula. How optimistic can we be? Well, let me start with another pub quiz. What's the next number in that row? Anyone? 5. And in this row? 16. Huh? And in this one? Well, I'll tell you what. The answer to all of the 3 was 42. And I will say, hang on. Why? that's simple because 42 is because all these numbers are the zeros of that term, right? Same for the second one, same for the last one. And yes, I could have chosen any answer I want, right? You say, why is that relevant? Well, it illustrates an important point. We only have, for anything we do in science, we only have a limited amount of data points, right? For example, if you analyze how the feeling of self-love depends on the number of donuts consumed, right? You might have 3 data points, right? So 1 is 1, 2 is 2, 3 is 3. And now you will say, okay, that's a straight line through them, right? And that's a fair assumption, perhaps, but it is not the only solution, right? It could be any of these curves. So maybe something worth remembering as well. We make an assumption when we look at this world. We make the assumption that, if possible, something should be linear because that's simple, right? Occam's razor, right? An explanation is correct if it is the simplest explanation. We have done well with that. But maybe we should remember it is ultimately an assumption. And maybe aliens prefer weird curves, right? And then we might have a hard time understanding their answer. So, yeah, but I will skip that. Now, understanding the answer an alien gives might also mean that we have to be clever. And sure, we are all clever, right? But there is a cost to that. For example, human birth is a gamble of life and death. It got a bit better in modern days with the zero sections, but it is, well, traditionally it was a gamble of life and death. And why is that? Because the human brain is so big, and that means the head is so big and it has trouble getting through the birth canal. So getting a much bigger brain, at least just by evolution, would be difficult. Then also our brain is quite hungry. Something like 20% of the body's energy is actually used up by the brain, which only makes up about 2% of the body mass. So I would call that greedy. And you might say, okay, maybe we can shrink the brain, use smaller neurons, but then you get more noise, and that isn't helpful either. So maybe for the time being, we are pretty much stuck with our cleverness. So the aliens might just be cleverer than us. Tough luck. And then finally, can we actually understand the answer? And that's an interesting one, because that also leads to the question, can we actually understand our world? Can we understand our world deeply? Can we make sense of the world formula if there is such a thing? And well, the answer might be maybe not as much as we would like. And the reason for that is really quantum physics. If you shoot electrons through 2 slits, I mean, you would expect that electrons are particles. You get a random, well, scattering, like, yeah, you should just have a gun, right, and pump gun. It would not get interference pattern, right? It would look completely different. But you get an interference pattern. Electrons behave like waves if you send them to a double slit. Still, every electron is a particle. One electron hits the screen, and only after time you see this interference pattern emerging. And of course, the explanation quantum physicists gave was that really electrons are, or anything really, any particle is described by a probability function. So we don't know where an electron is. The electron itself doesn't know where it is until someone measures it. And that, of course, has given rise to the slightly infamous paradox of Schrödinger's cat, right? Which is killed with a probability of 1/2, and is still alive with a probability of 1/2. And as long as no one is opening the box, Is the cat dead? Is it alive? Is it in a strange superposition of the two states? Now, of course, if you ask any physicist, they will tell you it's no problem because a cat is a macroscopic system. And that is to a large degree correct, right? But at least if you ask me, there is still a nagging feeling that, yes, that's true. And yes, if you look at the mathematics, the more particles you have, the more it will resemble classical mechanics, the cat either dead or alive. But if you look at the fundamental laws of quantum physics, there is nothing in these laws which will tell us why a cat is not dead and alive at the same time. It gets worse. You can also do experiments which really are similar to you put two balls into boxes, and they could be orange or they could be, what do I say, yellow, or they could be, I don't know whether it's blue or red. It's supposed to be red. Yeah, yellow or red, right? But given that it's quantum physics, unless someone looks, we don't know. But what we do know is that if the one is red, the other one must be red as well. And if the one is yellow, the other one must be yellow as well. So now you put them in the boxes and you move with these boxes to the different ends of the universe, right? And then, say, Alice on the one hand opens the one, right? And she sees the ball is yellow. And if Alice sees that the ball is yellow, Bob will always see a yellow ball as well. But again, the ball was not yellow. It was in the superposition of being red and yellow until someone looked. And so how does that work, right? The boxes are at different ends of the universe. And so, and even so, the moment someone opens the box, something, in air quotes, happens at the other end of the universe. And that becomes really dodgy when you factor in relativity and Einstein, because all of a sudden this whole idea of cause and effect might be reversed. Now, of course, there are ways around arguing, okay, it's not really, there is no communication, and it is true, you would not be able to send any messages with that. It's just that the particles can be thought of as one object. And that may be so. But I think it tells us one thing. Reality is positively not behaving the way we experience it in everyday life. It is way stranger. And in particular, if aliens maybe have grown up on a world which is much more quantum physical than ours, maybe they would have a completely different understanding, because our brain is made for our world, right? For our everyday life. It should come as no surprise that our brain makes sense of our world and maybe does not make so much sense of quantum physics, because you don't really need quantum physics if a tree is about to fall on you or a tiger is about to devour you. So maybe that's different on different worlds. So to sum up, can we do science with aliens? We don't know. We just have to wait for the alien scientists to come. And then let's keep our fingers crossed that even though we will probably not find the world formula, if there is such a thing, but at least we might get some cool technology and maybe even some cool science out of it. But until then, we have to stick to our world, which is interesting enough as well, and enjoy some very metaphysical and very real cookies and tea outside. Thank you so much.